Do you remember when we went over the chain rule? We said find a substitute. So usually it was something like u, and then whatever that substitute was, tend to be the difficult part of the function. So, for example, if we had something like this, which we wanted to differentiate, we would let u equal that difficult part, and then we would do the differentiation from there. With integration, you can do the same thing. It's known as integration by substitution, which is the question that you see on the board there. Now, integration by substitution is a process that allows you to integrate complex functions. You're not always going to get the substitute though. So in this question, they've given you u equals 2x plus 5, and then u squared equals 2x plus 5. So they've told you the substitute. You're not always going to be told though. In some scenarios, they will expect you to think of or figure out what the substitute should be. Now, similar to the chain rule, where I said make the part of the function, or the part of the function that's making things difficult, make that the substitute, right? That's what you're going to do here. Here's what I mean by that. Let's say we had this function, and instead of root 2x plus 5, it was just root x. That's easy to do. You can convert the root x and things won't be so complicated. But you've got 2x plus 5. So you make u equal to 2x plus 5. What you want to do in integration by substitution is convert everything inside your integral from being in terms of x to being in terms of u. So the first step to do that is to rearrange your substitute equation. Rearrange your u equals 2x plus 5. And when you rearrange that, you get this. So now you have a substitute for x, which is now in terms of u. And we're going to plug that in now. So integral of u minus 5 all over 2. And then you've got root 2x plus 5. Okay, root 2x plus 5 is the same as root u, if u is equal to 2x plus 5. So this is u to the power of half. So now, this is one of our terms which we've substituted and now made into u form. The other one would be u to the power of a half. That's the second thing. So this is done, and then this is done. The last thing is the dx part. Dx means you are integrating with respect to x. But now our integral is all in terms of u. So we are expected to have du at the end. But it's not as easy as just sticking du in. What you need to do is differentiate your u equals 2x plus 5. So you want to work out du by dx, which will be 2. And now you want to make du the subject of the formula. So 2 dx. Okay? Now you want to make dx the subject of the formula. So a half du is equal to dx. That's what you're going to substitute for dx. So a half du. So that's that last one done. Now that everything is in terms of u, you can simplify your integral and then you can actually integrate. So try that. Try simplifying whatever's inside the integral, all those brackets, and then integrate for me, please. So after simplifying, you should have a quarter of, so you can have a quarter u 3 to the power 2 minus 5u to the power of a half du. So that's after factorizing out the 1 over 4. Now, you can take the 1 over 4 out and leave the bracket on the inside, which is what you are going to integrate. After integrating and after multiplying by that 1 over 4, you should have u to the power of 5 over 2 all over 10 minus 5u to the power of 3 over 2 all over 6 plus c. And now the last step is to plug in what your u was equal to. So 2x plus 5 all to the power of 5 over 2 over 10 minus 5 2x plus 5 all to the power of 3 over 2 over 6 plus c. There you go, done. That is how you do integration by substitution. So a little recap. You convert everything from being in terms of x to being in terms of u, according to whatever your substitute is. You take it one term at a time if you can. After putting everything in terms of u and du, you would then simplify your integral, and then you integrate as usual. Then you plug back your substitute. That was part A, where your substitute was u equals 2x plus 5. In the other case, part B, you have u squared equals 2x plus 5. In this case, you would do the exact same thing, except your process or what's going to be inside your integral will be slightly different. Because now, u is equal to root 2x plus 5. So, integral x, and then I can just plug in u. If I want the x, I can do u squared minus 5 all over 2 equals x. So let's rewrite it. U squared minus 5 all over 2, and then u, and then you want to have the du there, right? In order to get the du, you need to implicitly differentiate u squared plus 2x plus 5. Sorry, u squared equals 2x plus 5. So this would be 2u du by dx equals 2. So you end up with u du by dx. You end up with u du equals dx. Like this. And now you're ready to simplify and integrate. The process is the same though. Okay, let me go through one more, and then you're going to try some on your own. In this case, they've given you the substitute. Cool. So if u equals sine x plus 1, what does du by dx equal? Equals cos x. Okay, now if we take that dx to the other side, we get this, which ticks both of these in one go. Okay? Now, the 1 plus sine x all to the power of 3 would be the same as u cubed. That's this part done. And then u minus 1 equals sine x, which is just rearranging the initial substitute, would give us that final one. So our integral would be u minus 1 in brackets, u cubed in brackets, and then du. Now we can simplify and integrate. So u to the power 4 minus u cubed du. Let me rewrite that 3 and 4. There we go. And now integrating gives this. So sine x plus 1 all to the power 5 over 5 minus sine x plus 1 all to the power 4 over 4 plus c. There you go, done. Okay, I want you to try these two questions. But for the first one, I'm going to tell you what the substitute would be. For the first one, you want to let u equal x plus 1. For the second one, I want you to work out what the substitute would be. Can you give both A and B a go, please? Okay. When we differentiate, should get just 1. And now u equals x plus 1. So that means u cubed equals x plus 1 cubed. And u minus 1 equals x. Okay, so we've got this, and this would end up being du equals dx. So now we've got that. Okay, in this case, you also want to adjust your intervals. Your intervals, this 2 and 0, is also in terms of x. You want it in terms of u. The way you're going to do that is by substituting it into your substitute. So u equals 2 plus 1, u equals 0 plus 1. So 3 and 1. 3, 1, and then your substitute. So the x is u minus 1, then u cubed, then du. My apologies, I didn't mention that before. I'm sorry, that's my bad. Now that I have mentioned it, do you want to finish this off? And also, maybe you might have to retry part B again. Sorry, my bad, should have mentioned it. From here, you would have u to the power 4 minus u cubed. This is what you are integrating from 3 to 1. So u to the power 5 over 5 minus u to the power 4 over 4. 3, 1. And then now you just have to substitute. So 3 to the power 5, 243 over 5 minus 81 over 5. So that's me plugging in 3. And then 1 over 5 minus 1 over 4. So final answer would be 28.4. Okay, that's that one done. The next one. I didn't give you a substitute for this one. You were expected to work out what the substitute would be. The thing making this complicated is the 1 plus sine x. If it was just x, it would be a bit easier. So you're going to let u equal 1 plus sine x. Du by dx would give cos x. So du is cos x dx. Okay, when x equals pi over 2, u equals 1 plus sine pi over 2, 2. When x equals 0, u equals 1. So your integral would be from 2 to 1, and then you would have root u du. That's it. So 2, 1, u to the power of a half du. So 2 over 3 u to the power of 3 over 2. 2, 1. Substitute minus 2 over 3, 2 root 2 minus 1 inside form. There you go. That is integration by substitution.